Good morning, students. In the previous classes, we have studied the methods for obtaining the initial basic Fourier solutions to transportation problems. In this class, we will extend our discussion to find out optimal solutions to transportation problems. And a well-known method is UV method, also known as modified algorithm method, for finding the optimal solutions to transportation problems. So, considering the earlier problem or the transportation table where we were having three supply centers S1, S2, S3 and four demand centers D1, D2, D3, D4, and there were certain supplies and demands. Okay, now here in order to obtain the optimal solution, first we find the initial basic Fourier solution, so that is obtained by any of the other methods used, and this is that initial solution where this 1 is allocated in S1 D1 cell and 5 is allocated in S1 D2, and similarly we have allocation here, here and here. Okay, after that we want to check whether these allocations are optimal or not. Okay, so we use this UV method. In this method we compute the quantities like UIs and VJs corresponding to all the rows and columns, right? So we start with any of these UI or VJs, okay, taking that equal to 0 so that we can find all others, okay, using that. So here I've taken U3 equal to 0 because this UI, that is U3, is corresponding to 3 filled cells in this row. So one should choose that UI or VJ equal to 0, which corresponds to maximum occupied cells, right? So, and after that, by using the filled cells, one can find out the all other values of UI and VJs using this relation Cij equal to UI plus VJ. Okay, Cij are corresponding cost per unit costs of transportation in the ijth cell, okay, or in the ith row and jth column, right? So suppose this u3 equal to 0, if I use this one, this filled cell, and here the value is Cij value is 5, and it is just like C31. So C31 is equal to 5 is equal to U3 plus V1. So V1 we don't know, okay. So we can find it from here, C30, U30 and V1 like this. So this implies V1 equal to 5. Similarly, we can find out V3. V3 means here, this is U3, V3, that is 15. Okay, the 15 is equal to 0 plus V3. So V3 equal to 15. Similarly, we can find out this 9. 9 is equal to 0 plus V4, and this therefore V4 equal to 9. And similar way we can now use, once I know this and this, I can find out across. So this value I have, this is filled cell, so I can use this one and this one means C11, and I can find out this U1. Similarly, I can use this to find out U2 and so on. So these are the further calculations that you can see here. So I have found here U2 equal to -8, sorry, U2 equal to -8 and U1 equal to -3, V2 is equal to 6. So this way we have found all these UIs and VJ. What after that? After that we find out certain values like DIG values, okay. So these are also just like net evaluations, okay, and their value is DCij minus UI plus VJ. Now these net evaluations must be positive greater than equal to 0 for all unoccupied cells. Okay, and let us find out all that. What are the unoccupied cells? Let's go back to this table. It is this one: 1 3 1 4 2 1 2 2 2 3, and this one 3 2. Okay, so these are the unoccupied cells. We will find out now the DIG values for. So for 1 3, D13 is equal to CIJ is 11 over there. So 11 minus U1 plus V3. So these are values given over there. So if we do this, I find minus 1. Okay, minus 1 is less than 0. Similarly, D14 can be found 7 minus this plus this, and it is 1 greater than 0. D21 is equal to 1 minus 8 plus 5. 4 greater than 0. D22 is equal to 2 greater than 0. Similarly, D23 is equal to 6 minus 8 plus 15 minus 1 less than 0, and for D32 it is 2 greater than 0. Now all the DIG values corresponding to empty cells are not positive or 0. Some are negative. So what we do, we select the most negative cell in the table. Okay, we select the cell corresponding to most negative DIG value in the table and start a loop from there. This is the next step. Okay, but since here D13 and D23 both are having equal values, minus 1, so it is up to us which cell to use to develop a loop. Okay, arbitrarily you can make a choice. So let us go back to the same thing table here. So I am selecting this one, D23 cell. Okay, so now what we have to do, we have to make a loop which must pass through the occupied cells only, and the movements are rectangular. No diagonal movements are allowed, and the loop can be in either direction. Either you go clockwise or anti-clockwise. So suppose I start from here and the loop is going to this, and loop must pass through the filled cells. So it's going to this and then coming here and here and here. It could be in other direction, reverse direction also. Okay. So once we develop a loop, after that, assign positive and negative signs alternatively throughout the loop to the cells. But assign positive sign to the cell from where the loop is originating, starting. So to this cell I am assigning positive sign, then negative, positive, negative. After that, what you have to do, you have to find out the minimum of quantities allocated in negative sign cells, right? So this is negative sign cell and this is negative sign cell here, and the allocations are 1 and 3 in them. So minimum is 1. Minimum of 1 and 3 is 1. So what to do? This minimum quantity should be added to positive sign cells and should be subtracted from the negative sign cells. So here in this cell, what is here? It is empty, so it is just like 0 allocation. So 0 plus 1, 1. So this cell now will become occupied and 1 will be allocated to this. Similarly here 1 minus 1 is 0, so now this will be empty. Then here 1 plus 1, here will be 2, and 3 minus 1, again here will be 2. All other cells will remain unchanged, their allocations, everything will remain unchanged. So there are some changes. Okay, Some cells are becoming basic and some are non-basic. So this cell is becoming basic cell. Here there is some allocation and here is no allocation. Okay. So let us go ahead. After that, yes, this is the story. And yes, here we reach. Here we reach. This is 1, empty, 2, 2. Okay. This is the new scene before us now. This is the new transportation table, or this is the new solution now. Okay. New basic feasible solution. Now we have to check this for optimality, whether this is optimal or not, because there is a change. Earlier here it was a occupied cell and one was here. Now one is here. Here was something 3 or 1. So things have been changed now. Okay. Again, you find out UIs and VJs. Okay. So corresponding to these rows and columns. So what to do? I started with this U3 and I chose U3 equal to 0, and then with these filled cells I can very easily find out that U1 is V1 equal to 5 and V3 equal to 15 and V4 is equal to 9. So with the help of these 5, 15, 9 and 0, I can find out U1, U2 and V2 as we have, this one, V2 as we have done earlier. Using the relation Cij equal to Ui plus Vj. You can see I have done it here. So U2 came out to be -9, U1 came out to be -3, and from here V2 is equal to 6. So these values are put over here, right? After that, again, we have to find out the Dij values for all the unoccupied cells. What are unoccupied cells? D13, D14, D21, sorry, this is 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, and 3, 2. So we can see here is, so now we have to find out D13, D14, D21, D2, D24, D32. And these net evaluations, now if we see, these are 23, 1, 5, 3, 1, 14. That is, all these are greater than equal to 0, greater than 0 rather. So this means that all Dij greater than equal to 0, therefore solution is optimal. Hence the optimal solution is given by, so optimal solution is provided in the above table, that is this table. Okay, and it is given by x11 equal to 2, that is, you can see from the table, x11 equal to 2, x12 equal to 3, x23 equal to 1, x31 equal to 6, x33 equal to 2, x34 equal to 2. And we can see here 3 equal to 2, x3 equal to 2. So this is how the optimal solution can be written. Okay, you have to write the optimal solution like this. Okay, and then after that you write minimize z, that is minimum possible cost of the this transportation problem, or the minimum total transportation cost, minimize z, that is equal to 2 into 2, means allocation is 2 units and the rate of transporting by unit is 2 in that cell, 1 1, and similarly 3 into 3 plus 1 into 6, 6 into 5, and so on. And if we multiply and add, we get 97. So this is the minimum possible transportation cost, optimum transportation cost provided by this UV method. So 2 into 2 plus 3 into 3 plus 5 into 6 plus 2 into 15 plus 2 into 9 and 6 into 1, all that. That's how we find out this. Okay, so in this class I have illustrated that how UV method works. Okay, thank you.